solve sine 3x equals minus 1 over root 2 for 0 degrees less or equal to x less or equal to 360 degrees. Give answers to one decimal place. So we know that sine 3x equals minus 1 over root 2. Therefore, 3x equals 1 over sine into bracket minus 1 over root 2. And using the indices, that will be sine to power minus 1 into bracket minus 1 over root 2. So that's 3x. Get the calculator and find the sine. So we do shift sine. We want a fraction, so we press the fraction button, minus 1 and divided by root of 2. So we need to close the square, we need to close the bracket, equals. So that's minus 45. So therefore, 3x equals minus 45 degrees. So now we're going to use this to find the solution to the sine 3x. We're going to use cast diagram, and we'll use the sine function diagram. So we can show two ways of doing this. So using the cast diagram, so I've divided the circle into 4 parts, the 4 quadrants. First quadrant, second, third, and fourth. Sine, so 3x equals to minus 45 degrees. Now, 45 degrees is right here. That's minus 45 degrees here. So actually, let me just draw that all the way through. Just roughly 45. And also, if I do this, to just roughly make it 45. Okay, so this one here, if I bring the line down, so that will be the sine, because sine of x is 45 degrees here. And sine of x here is also 45 degrees here, because the y values are the sines. And this one here though, the sine of x here is minus 45. So the sine of x here at the bottom is minus 45. Because, so using the cast diagram, all are positive here. All is positive. Sine is positive here. All positive. All the trig ratios are positive. Cosine is positive here. All positive, that's what that stands for. S means sine is positive here in this case. Here, tan is positive. So tan is positive. And here is cos is positive. Cos is positive. The rest are negative. So that's cast diagram. But for the here, this is 45 degrees. So that's plus 45 degrees, obviously. This one is 135 degrees. Again, that's 45 degrees there. That's 45 degrees there. Or y is positive, so same value as y is positive there. And here, you might say that height is 1 over root 2, that distance here, the height, so that's what sine x is. This one is also, that distance is 1 over root 2, again that is sine x. So that's 1 over root 2. But we're not interested in 1 over root 2. We want the negative value. So this one here is minus 1 over root 2. That distance here from there to there. So that is sine x here. But this is negative here. So, but the angle here is 45. This is 135. And this one will be 225 degrees. Because you add 180 to 45. That's 225 degrees. Here you add 90 to 45, that's 135 degrees. And here you add, or you take away, or you add 270 to 45, or you take away 360, 45 from 360, so that's minus 45 as well. So that's 45. So that would be 315 degrees. So the angles that we are interested in are, we're interested in these angles here and that one. So that will give us, because this distance here is minus 1 over root 2. That's that distance here. So that's the sine x. Sine of x equals minus 1 over root 2. The sine of x equals minus 1 over root 2 is here. So because it's below 0, so this is 0. The x value here are for cosine. So we're not dealing with cosine today. So we're dealing with the sine right now. So those are the values we're interested in. And therefore, we could write this value down as x. We could write it here. X degrees equals the first value. This is for 3x, by the way. So I'm just going to say 3x degrees, or just say 3x. So we're writing it for 3x now. But these ones are for x, right? So for x, that means you go round once. That's what that meant. Because you've got 1x, sine 1x. That means you go round 1. So when we go round 1, from there, we go round up to all the way to there. That's the first one we need. And we get 225 degrees. And then the second one we need is we go around from there all the way to this angle here. So that would be, the angle there will be 315 degrees, because that's when it's minus 1 over root 2. And then we need, that's for the sine x, sine 1x. Now we need to do sine 2x, because it's sine 3x. So we have to do another time again. So not just once, you have to do once again. So you have to start from here now. So we're here now, because we just found 315. Now we need to do all the way from there, all the way back to here. So we have to come, so the second time we have to go from 315 all the way to 225. And what are we doing? We're adding, see, this is 45, 45. It's like 360 take away 90. So 360 less than 90 is what we're going away. So that'll be 270, isn't it? So if I do, I'm just going to do, let's just do 180. So if I do 360 minus 90, that's 270. So that means we're adding 270 to here to get back again. So you do 315 plus 270. So that'll be 315. So that's what we're going to do, plus 270. Boom. So that's 585. 585. So the next one along will be 585. So that'll be 585. Right. So after that, then we have to do, we have to go back to here now. So 585, this is 585, so that's 585 degrees. Now we have to go all the way to there now. So 585 plus 90. So 585 plus 90 should give us 675. So this will be 675 degrees. So that means we got another one, 675 degrees. Now that's for 2x now. So we've done 2x. 1x, this one here, 1x, 2x. Because now we go for 3x. That means we have to do it the third time. So for 3x, we're going to go all the way by adding 270 to that one now. So 675 plus 270. What will that give? That should give 945. Let's just try to make sure we check these. So 675 plus 270, that's 945. So 945 will be there, 945 degrees. And so that will be the third one here. So that will be 945 degrees, because it's third time, so that's 1x, 2x, and 3x. And then we're adding 90 to that. So adding 90 to 945 will give 1. So that will be 135, I presume. 1, 3, sorry. That will be not 1, 0. So that will be 1035. Just to check, so it's easy to make mistake. So 945 plus 90, 1035. So that's 1035. So the third one, the final one is 1035. And that's how you work out your 3 sine x. So that's 3x equals minus 45. And we have to do it 3 times to get those angles to go once. That's for 1x. 2, that's for 2x. 3, that's for 3x. Now that we've done that, what we now need to do is, this is for 3x, but we need to find a value for 1x. Because the question is asking for between 1 cycle, not 3 cycles. Even though it's giving us 3x here, we want 1 cycle. So that means we have to divide all these by 3. So to get x now, which is what we're looking for, so that right here. So for x, we have to then divide that by 3, 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 divide that by 3. So we're going to get, so when we divide that by 3, we get, so we should get 75 degrees. So that's that. 315 divided by 3 should be 105 degrees. 585 divided by 3 should be 195 degrees. Now 675 divided by 3 should be 225 degrees. And 945 divided by 3 should be 315 degrees. And finally, 1035 divided by 3 is 345 degrees. And that's the value of x we need. And that's all there is. But we can also do this question using as sine function. So if you have a straight line, just draw a straight line through that and that. Hopefully you can see that. And for the first sine wave, start from 0. This is the first sine wave, goes like that. That's the sine wave. That second sine wave start from 360 all the way back again. And the third sine wave starts from 360, goes back again. So now we could put the values to these sine waves. So this is pi. That's 2 pi. So this is 4 pi. And that will be 6 pi. So right, this is pi, 2 pi, and that's 3 pi, 4 pi, 5 pi, and 6 pi. Or you could say this is 180 degrees, and this is 360 degrees. This is 720 degrees, or you might say that's 540 degrees. This one is 900 degrees. And this one is 1080 degrees. 1080 degrees. And so that's the y there, and this is your x values. But we're looking for minus 1 over root 2, which will be along here. So that's minus 1 over root 2. And if you get your ruler and just hopefully draw a straight line. It's not the best curve, so this is just a rough estimate. So just draw a straight line going there. So that's the straight line we drew. So this one here will be the 225 degrees, and this will be, because it's 180 plus, you can see that's 45 there, 180 plus 45. And this one is 360 minus 45, so this will be minus 45. So that will be 315 degrees. And here will be plus 45 for 3 pi plus 45. That's 540 plus 45, so that will be 585. And this will be again 720 minus 45, which is that will give 675 degrees. Here will be 900 plus 45, because that's 45, then that's 945, so that would be 945 degrees. So you can see those values, and here will be another 45 before 1080, so 1080 minus 45 will be 1035. So you can see you can work out those degrees, and those values are for 3x equals. Now we need to find for x. You just divide by 3. So if you divide that by 3, you get 75 degrees, and that is 105 degrees, and this one is 195 degrees, and this one is 225 degrees, and this one is let's say 315 degrees. If you divide it by 3, divide that by 3, you get 345 degrees. So that's the value of x. Those are the values of x that we are looking for. You can do those using the cast diagram. C for cos, A for or, S for sine, and T for tangent. You can use that to do that, or you might just use a straight sine function diagram to do that. So this is y. So the sine function diagram here is y equals to sine x. So the expansion here, it's all, you can see that's all for 3x. You can see that's why we say 3x. So that's for 3x, and each one is an x there. So that's an x there. So that's an x, x, and x. And that's why we divided by 3, because it wanted it for 3. It wanted the result for 1 oscillation, and this is for 3 oscillations. And that's why we divide all by 3 to get the values of x.